Hi, I'm Bob Whiten. I'm the product manager for HILCO, and I'll be your instructor for this series. Virtually every practice has some sort of system of small parts. For our example here, I'm going to be using the Smart System Pro, which contains all the repair parts that I need for any type of repair work, as far as all the screws and nose pads and temple tips I have a use for. Here laid out on the mat here, we have the different types of screws that are contained in this system, and they're both really a good type of screw to have on hand. The first screws here are your standard replacement screws. Those are used in applications where you were able to remove the screw without damaging the hardware of the frame, or if a customer walks in and the screw has just backed out and you need a replacement screw. That's the type of screw to use. It's really an OEM equivalent. It has a specific diameter and a specific length and a specific head size to fit the need. Above that we have repair screws. These are self-tapping stainless steel screws, and primarily they're used when the hardware in the frame is damaged, whether you've drilled out the frame or the customer maybe stepped on the frame and the screw was ripped out and damaged the hardware. You would use a repair screw, and really the only critical dimension on that screw is the diameter. You'd want to use a screw, you tap it in, the excess screw comes out the bottom of the hardware and you snap off the excess. There's no need to worry about the length of the screw. Both those types, replacement and repair screws, are included in the system, and it's a good idea to have at least some of these two types of screws on hand. For nose pads, many practices inventory all different styles and kinds of nose pads, different materials. There's plastic and vinyl and silicone. There's screw type. There's push-on type nose pads. There's a system devised called Logic nose pads, where it has a patented assembly, and the pads fit both the screw type and the push-on type, so there's no need to inventory both anymore. They're made out of a premium silicone material. They have a unique oval design in which 4 pads actually replace 20. There's a 17 millimeter oval, a 15 millimeter, a 13 millimeter, and then a 9 millimeter round button, which is the most popular round button pad out there. Also contained in the kit is an assortment of temple tips whenever we need to replace those as well. So typically, any of these or all of these are inventoried at any particular practice. Now that we've removed the screw from the frame and we haven't damaged the hardware, either we used a ribbon file or were able to get it out with a screwdriver and the hot fingers, or using the screw extractors, we need just a replacement screw to put into the frame. And one thing to keep in mind is that in today's optical industry, 1.4 millimeter is by far the most popular diameter used in both the hinge and the eye wire. That's a great starting point if you have no other means to find what screw that you need for the job at hand. But there are gauges out there, such as the Fast Find screw and hole gauge, which you can quickly find what diameter screw you need and the length by using this gauge, and it works very simply. Here we have a temple and a frame front where we have to find a replacement screw for. Now, what I need is the diameter of the hole on the bottom. That's where the screw is going to thread in. So I'll take this pin gauge and I pass the pins through. Let's see, we'll start at 1.2. I will pass the pins through until I find one that fits snug. 1.2 is too small, 1.27 is too small, 1.4, that's pretty snug, 1.5, it's a little large. So it looks like it's going to be a 1.4. Now we know the diameter of the screw. To find the length of the screw, you take the ruler that has notches in it and has a corresponding number for the length of the screw. It's going to be a 3.5. So I need a 1.4 by a 3.5, and then you can go into your inventory. All of HILCO screws are labeled by diameter and then length. So I have my 1.4 by a 3.5. Spill out one of the screws. And then we can insert that into the frame. And that's how you find a replacement screw. If any of the previous methods of screw removal didn't work for you, by using either the screw extractors or the ribbon files, and you want to try to punch out a broken screw, many people try using a staking tool. It's kind of an old-fashioned method, and I find that it can be a little cumbersome trying to fit the different frame styles in this tool to try to get it to line up with this pin and punch it out properly. The tool was really designed to aid in repairing rivet hinges, and sometimes if you're lucky enough you can get it to punch out a broken screw. But there are pliers out in the market that are available that work much better than a staking tool because they get into much tighter areas. One of those tools is called a zapper plier, and this is designed with a shorter pin than a staking tool. It has a jaw down below to receive the screw that we're punching out. We're going to punch out the screw from the bottom, and it will work in every application in the hinges and most of the eye wires as well. And I have a frame here that has frozen screws, and I'm going to try to punch those out. And we'll do the temple hinge first. And what we're doing is we're lining up the head of the screw to pass through that opening in the jaw. And we have the pin over here that's actually going to punch out that screw. And it's important to get the pin close to, as close to center on the screw as possible. Make sure that the head of the screw is passing through the jaw, and then you squeeze it. And it punches the screw out. Now we'll try it in the closing barrel as well. Once again, getting the punch as close to the center of the head of the screw as possible. Squeeze it. It punches it through the threaded portion of the closing barrel, and then we can just pull the rest of the screw out the remainder of the way. Now, by using this method, one of two things is going to happen. Either the screw is going to strip, or the hardware in the frame is going to strip. And I find the best way is just to go right to a repair screw and forget about trying to finagle a replacement screw in there. I want to use a self-tapping repair screw so I can tap new threads into the frame. So I will do that by taking the screw that I just punched out. I want to find the diameter of this screw. And the fast find gauge also has holes in the ruler where you can pass the screw through the holes to find one that fits snug. There it is. It's a 1.4. So I know what diameter repair screw that I need. I'm going to go to a 1.4. Now, you might be thinking, you just punched out a 1.4 and it's stripped. Why are you going to a 1.4 repair screw? That's going to be my starting point. It may or may not work. If this doesn't work, a 1.5 is going to do the trick. And once again, the vials are labeled 1.4. Spill out a screw. And we'll put this one in the closing barrel. Pass it through the bottom. Get it started. Right now, I know that this is going to be just a little bit too small because the threads are passing through the closing barrel, but it's a good starting point. I'll thread that all the way down just to be assured, and it probably won't tighten up, which is okay. I can just back that out. And if you jumped right to a 1.5, it would just cut new threads anyway. I just want to come as close to that hole diameter as I possibly can. So I jump up to a 1.5. Insert that. Yeah, and I can feel it's really starting to cut those threads. Seat it all the way to the bottom. Tighten it down. It's not stripping out. Perfect. So we did have to use a slightly larger diameter size. Now I'm going to use an Ergo Pro plier, the chain nose. This I find is the best tool to snap off the excess of the stainless steel repair screw. And what you want to do is grab the screw as close to the bottom as possible and then twist it. It'll break within 1 or 2 twists. You can twist it back and forth. It broke right on the first try, broke off nice and clean. The customer will never know that that's a repair screw, and it looks much better than the old nut and bolt repair where you put a lens screw through and then a nut and socket home, especially on expensive frames. Usually doing that to a real expensive frame is not going to make your customer all that happy. Drilling out broken screws is the last measure you want to take in screw removal. Anybody who's drilled out broken screws knows that it can be a real pain in the neck, and it's not an easy job to do. We have devised a tool that virtually eliminates all the hassles in drilling out broken screws. Now, the first thing that I'd like to explain about drilling screws, whether it's freehand or whether it's with any type of guide, is that you always want to drill the screw out from the bottom of the screw. And the reason for that is the screw threads that are holding in place are at the bottom of the screw. So if you attack the screw from the bottom, you only have to drill through a small portion of the screw and then the remainder falls out. If you attack the screw from the top, you have to go through the head and the entire length of the shaft until you get to the threaded portion, and there is more margin for error there at the drill going in at a slant and then ruining some of the hardware on the frame. So the device I'd like to show you today is called the Bullseye Screw Drilling Guide, and it is made out of a tool steel, and this device is used to clamp down over a broken or frozen screw, whether it's in the hinge or the eye wire. And this shaft here that turns, that's how it clamps down onto the frame. But there's a hole that runs the entire length through that shaft, and that's actually the drill guide. The drill will pass through that, or hit the screw, drill out the portion that you need, and the rest of the screw will fall out. The kit comes complete with the drill bits that you need, so you don't have to worry about the drill bit size. You'll have some to start out with. And there's also a laser etching on the top of the guide, 0.043. That is the drill bit size that is used with this guide. That happens to be very close to 1.4, which is probably the most popular screw in the industry. And it'll knock out anything from a 1.3 to a 1.6 screw with no problem. So here we have a frame that we're going to drill out the screw in the eye wire. So I'm going to take the device. Okay. Now the eye wire screw goes up from the bottom, so the head of the screw is down below. So I want to drill the screw from the top of the frame, but it's actually the bottom of the screw. So I'm going to clamp down this device. It's actually designed so it self-aligns itself. It doesn't matter if the screw is countersunk or if the head is sticking up out of the hardware. It will either seat itself in the hardware or grip the screw entirely. Once I get it just very, very light, I don't really tighten it down, I just give it a little wiggle, and then sometimes it'll snap right into place, and it did for me just there. So I know it's perfectly aligned, and then just finger tight. You don't need a wrench or a plier to tighten that down. Now we're gripping the screw top and bottom, and we're ready to add a little bit of oil. I use this pinpoint oil that has some cutting oil in there, which is the best oil to use for drilling. And using oil is absolutely necessary. If you don't use it, you really risk the chance of the drill bit binding in the guide or even in the screw if you're drilling freehand. And if you break that drill bit off in the frame, you're really talking about looking at some soldering work. There's no way you can drill out a drill. So now that we have everything in place, I have my drill bit ready in the Dremel drill. I'm going to turn it up to about a speed of around 3 or 4. Use my anvil as a brace. Now when using this, I drill a little bit and then back it out, and you can see the shards of the screw coming up through the top. That's exactly what you want to see. Now you'll know you've